I got to know that you're mostly the first years and second years. So here the thingy, okay, the thingy, it can be basically anything. Okay, it can be from persons. Okay, I really wondered why IoT can be implemented, or the Internet of Things, and the thing can be termed as a dog. A dog or a cat can be a thing. And can you give me an example, a latest example where this Internet of Things is associated with the pets, dogs, cats, example, etc. Anyone? Do anyone know any latest technology or a latest innovation that has introduced?
So
Yeah,
CyberTalk by Xiaomi and
yeah,
other companies.
correct, correct. That's one of the examples. Thank you for that. And if you heard about this, what do you say, the Apple, what was the product name? Apple uh,
Air tags.
AirTags. Yeah, thank you for that. Thank you for that. Yeah, AirTags. Have you seen these things? See, they're selling for a price of
Yes.
2,700 rupees, and you can connect these things to your pets. You can connect this to your dog, connect this to your, what do you say, the cat, and your phone app will be literally showing where these your pets are. Okay, so things have been advanced over the time, and in such a way that the Internet of Things and the thing can be anything, starting from a very
Like
small
GPS
pet.
also.
What?
Like GPS, the AirTag will work, sir.
It's not like a GPS. It's actually connected through the Bluetooth, but it's having very precise point. Like in a Bluetooth, you will be having around 10-meter radius, right? You will be having a 10-meter radius, or it's 30 feet. Okay, it's 30 feet. And if your pet is situated somewhere here, you can exactly point out from how many feet. Let's say 22 feet. You can sort out to a resolution of 1 feet. Okay, so this is the advantages of using Bluetooth. But if you're using a GPS system, okay, even you are using when the Google Maps, if you are using, you can see that it says the shop would be 10 meters away. Okay, 10 meters away. And even if you are, let's say, half meter away from the shop, it will again show you, or 1 meter away from the shop, it will say that you have arrived at your destination. So the precision of the Google Maps, which is working under GPS, it's around 3 meter. Okay, the precision. And when it comes to the Bluetooth, Wi-Fi, all other technologies, the precision is up to 1 feet. Let's say 10 to 30 centimeter. So the precision is more in the case of Bluetooth, and the AirTags work on the principle of Bluetooth. Okay. So what I understood is that things have revoluted over time in such a way that the thing can be extended from very pets to the agriculture, automation, energy consumption, security, everything. Okay. So every single thing in your house, in a single thing in the world, can be associated with the Internet of Things. Okay, this is a very simple introduction to the thing, how this thing is working. And so this is a lot of content here. You don't have to go through that. So we can break it down. Can anyone say automation or let's say automation project? We are going to build a automation project. Can you suggest some of the automation project that you need in your house? Any automation project that you
Motion
would like?
sensing lights.
Motion sensing light. Okay, thank you for that. Motion sensing light. Any other? Any other one?
Wi-Fi enabled lights and fans.
Lights and fans. Okay, let's go for the fans. Fans IoT. Anything else? Anything else? Any relevant things that you would like to add? Let's say
Refrigerators.
refrigerators. Yeah, refrigerators. We can go.
Alexa?
Alexa. Yeah, of course. The IoT. Oops, sorry for that. Actually, I'm sorry for that. Yeah, actually, it turned on here. Okay. Anyway, so the refrigerators, and the other example I can give you is a automated water pump. Okay, automated water pump. So let it be there. Let these examples be there. We can discuss that through the way. Okay, let's for the time being, let's skip this slide. Components of IoT. You can go like there should be some communication protocols. Let it be Bluetooth, Wi-Fi, Z-Wave, Zigbee, LoRa. Any of the communication protocol must be there. Sensors. A lot of sensors can be integrated to the system, and you should have a cloud where all these things can be interconnected. And you should be having a motherboard, something like a Raspberry Pi or a Arduino. We will come to that later. Before that, the IoT benefits. Okay, as you're beginners, I'll start from these things. Improved customer engagement and the technical optimization. For these 2 points, I can give you a simple example. I in 2020, I guess it's November 2020. Uh, Sorry, 2021. Okay, 2021. The last year, around 3 to 4 months back, I bought a fridge. Okay, I brought a refrigerator. I don't remember the model name. It was something Samsung's, and oops, my handwriting. Samsung. Okay, it was Samsung's refrigerator, and it was rated for around, I guess, 430 liters. Okay, it was the price of this thing was um, with all those discounts and stuff, I got it for 38,000 rupees. Okay, so this is an overkill. This is an overkill, absolute overkill for my house. Actually, we were having a 200 liters previous model in my house, and as you might know, like the Indian households, when you open the fridge, you can see the whole universe there, right? You can see the whole Krishna's universe. Like when the Krishna opened his mouth, it shows around 9 planets, all those surrounding things. And the similar thing happens in an Indian household refrigerator. When you open the stuff, you get the things from like around 2 months back. Okay, it was similar in my situation also. We upgraded that fridge to around 430 liters. And when I go to that showroom, I happen to see there was a fridge. Okay, actually, I didn't assume it to be a fridge. I saw something from the, what do you say, the Iron Man movie. Got to know that this is something from the Iron Man movie, I guess. Okay, so I asked the shopkeeper, so what is this? What is exactly this thing? He told that it's the Samsung's IoT enabled refrigerator. Okay, and it was like this way. It was something like this one. If you see, it is having a double door, and literally it was having a 11-inch screen here. Okay, 11-inch screen. It was having what do you say, the door handle, which is like half of my height. The handle was half of my height, and here it was having a beverage setup. Like you can take the liquor and all those stuff. You can take the soda, all the stuffs here, and you have the small Wi-Fi antenna sticking out from here, and the whole thing consumes around 230 watts. Okay, 230 watts is simply equivalent to two of my Xiaomi TVs. Okay, okay, so this thing is a damn powerful, and it's when you open that, it's perfectly to suit two two people. Two people can be perfectly suited in this thing, and it was around 600 liters. Okay, I asked what is the real advantage of this thing. So, and the funny thing is that it was rated for 3.2 lakhs. If you go to the Samsung's website, it is still there. This model is still listed there. Okay. And when I asked that, what exactly this thing do? He told me that it is having a IoT. It is having the Internet of Things. And whenever there is a complaint in the refrigerator, let it be the technical issues, let it be the refrigerant issues, let it be the LCD panel, any upcoming issues, okay, not this point, any upcoming issues will be forecasted, and will be sent to the nearest showroom. Okay, so that their service people will come to your house, repair that thing for free. The whole IoT will be analyzing your refrigerator, and it will be forecasting your upcoming issue, and it will send that to the showroom, sending the service people from the showroom to your house. See, that is the difference, and that is one of the advantages. Okay, so this thing is known as improved customer engagement. Customer engagement. I hope this point is very much clear, right?
Yes, sir.
Okay, done.
Yes,
And
sir.
the yeah, okay, thank you. And the second thing,
Sir,
yeah,
the issues are all automatically monitored, sir.
right.
Okay,
It will be having a data of the previous customer reports. So if something is missing, so this will be leading to one of the problems. So it will be having a massive amount of data, and it will be analyzing from that data only. Okay,
okay, sir.
and yeah, and the 11-inch screen. Okay, I asked again, why is this thing here? He told me that if your mom is at home, your mother can watch the TV from here. Watch the TV, watch the YouTube, premiere the Netflix films from here. Okay, why the hell in my mother is having a Netflix in your kitchen when she can just step out of that room and she can watch it in a very good screen? So this was one of the another advantages they boasted about. And one more thing, it will show a virtual image of what all things are situated inside your refrigerator. And he literally showed me that in this compartment, eight more eggs are there out of 10. So it is time to refill. And at the time when it is 3, it is 3x, this will send an automatic message, a notification through the Alexa app to my phone to add the X in my cart. Okay, so this is can be termed as the technical optimization and stuff. Okay, so what happens in every aspect, this IoT or the Internet of Things is making a man vulnerable to technology. Without this, he won't be surviving in a long day matter. And if you have gone through this very thoroughly, you can see that for all this technology, we are paying how many rupees more? See, we are paying around 4 to 5 times extra for this technology to happen in our house. Okay, so this is the very simple example why IoT, the benefits, improved customer engagement and the technical optimization. And if you know for the MG car, the MG Hector, all those cars are connected, are internet connected. So again, any downsides happening in your car, it will be sent to your customer care or the showroom service people. They will come to you. So all these things add to the customer engagement. And the reduced weight, I don't think it will reduce the waste anyway. There are points like the reduced waste is there. Then cost reduction, of course, cost reduction can happen. How? Because it won't be going through the verge. Okay, it won't be waiting so that the things getting depleted. Okay. Before that itself, it will give you an alert. The Internet of Things will give you an alert. Energy and efficiency is still a concern to be discussed. I'll come to that later. Why not? Okay, compatibility is one of the major issues why IoT can't be implemented nowadays. Okay, so if you see for yourself, if I make a IoT system out of Arduino and a Wi-Fi module, and you are making something out of NVIDIA or a Intel chipset, the both things are similar. The both things are same. Okay, you are using a Intel or a NVIDIA chipset to make a IoT system, and I am doing the exact same purpose using a Arduino. The both thing will be treated as similar. Why? Because as of now, there are no certain standards for the IoT systems. There are no certain standards. Okay, anything that you make, you can call it a IoT, no problem. The complexity, failure is another issue. I'll come to that later. And the security, with all this data up on in the air, you can literally be hacked by anyone outside who is well enough with the computer, well enough with the coding, well enough with the internet. They can hack into your data. Okay, I'll come to that. So these are some of the Internet of the Things devices. Philips Hue, it's a what do you say? IoT enabled light. You have the Amazon Echo, all those things. Google Home is there. Or IoT enabled doorbell is there. Camera, all those stuffs are there. So a lot of products are there in the market. Okay, till now it's clear, right? Any doubts? Any doubts?
No, sir.
Okay. So till now it's clear, right? Anything to
Yes,
be
sir.
okay? So I can show you some
Sir,
things. Yeah, tell me.
can you explain the technical optimization once again, sir?
Yeah, sure. Yeah, I'll go to that. Give me a minute. Which one was there? This one only, right? See, if I'm going for a single particular point, I can show you that. See, Tesla cars. Okay, Tesla cars, you know that. Tesla electric car. So they have created a very massive amount of data. They have a centralized cloud, and every single Tesla car is connected to this thing. Okay, every single Tesla car is connected to this cloud, and they're having their autonomous cars. So think of a situation in a line. In a line, your car is moving, the other car is moving, the other car is moving, all those stuffs are moving. And think of a situation where all these are Tesla cars, and they know exactly with how much distance you and the other guys. See, this distance is perfectly known, which means that there will be no more accidents if all the cars are connected to a central database. Okay, so this is one of the advantage. And if you're coming for the technical optimization, let's say T5. Okay, Tesla car number 5 is having some battery draining issues. Okay, battery draining issues is happening in his car. and his car has been bought 2014. It has been bought in 2014 November. Okay, and it's having some battery draining issues. And if you see, the production batch was let's say 276. This data, when the battery is draining, this data is sent to the cloud. Okay, sent to the cloud, and the cloud send this data to every other car. Okay, every other car, the data will be sent, checking for whether these requirements have been fulfilled earlier. T1, let's assume it has 2016, no problem. 2014, 2014, 2017. Okay, so these two cars won't be having that issue. So 2014 are isolated, and the November batch. Okay, November batch. These two are November batch. Again, sorting out, it will be having 276 the batch, and this one is 278 the batch. Now, this car might be prone to this battery draining issue. So the cloud will be sending a data such that you should be taking care of the battery draining issue in the further upcoming. Okay. So in this way, multiple data can be gathered, and this will be optimizing the overall customer experience. So this is basically meant by the technical optimization. Clear, right?
Sorting out the technical issues, sir.
What?
Sorting out the technical issues, sir.
Sorting out the technical issues.
That one only technical optimization, sir.
Right. So every single technical things will be allocated in a database, and from that database, the what do you say, the company can withdraw data, which means they can give for a particular scenario this will be the issue, or for another scenario this may be the issue. So data analytics, all those stuffs will be going in the behind place, and they can get a good technical optimization all the way throughout the way. Okay,
Okay, sir.
done. So just tell me if I'm visible. Okay. Uh, am I visible here?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
so yeah, so this
Yes.
is me. If you see here, let me show if I can. Okay, anyway, there switchboard is there, and I have connected my Internet of Things there. Okay, I have a system connected here, so I built that one. I'll show you that how I arrived at that all those steps. It's actually very tiresome. Okay, and I'm having two IoT devices here. The one is Amazon. I won't be calling her name. Actually, if I call her, she'll be Evik. Okay, and this other one is Google Home. Okay, I have two in my table. So I'll show you two problems. Okay, I'll show you two problems and some of the advantages. So if I say, Alexa, turn off the bedroom, see the complete thing will be shut down. Okay, so this is connected to the one of the outlets there and one of the outlets here. Two outlets have been interconnected. So this is one of the advantages of IoT. You can connect multiple nodes or multiple what do you say boards to a single cloud. Now I'm using the Arduino cloud here, so I can control the two individual things on my own. And if I say Alexa, turn on the bedroom, see this is one of the another issue. Okay, taking the data will not be interrupted every time the same. Okay, if I say again multiple times, I would have get the final result. I'll show you. Alexa, turn on the bedroom. See, the second time it activated, right? So this is one of the issues of, as I already told, there are no certain standards for the, what do you say, Internet of Things. So anything that I make on my own can be termed as IoT, but it won't be a perfect IoT. So if I say, Alexa, I guess, turn on the fan, the regulator speeds, see, that one has been turned on. Okay, so now you're getting my point, right? But what happens? It will be getting even more complex if I have to control the fan speed. Okay, if I have to control the fan speed, it will be very complex. Okay, so I have already fixed that speed to the third position, and here also the third position is already fixed. And I'll show you another disadvantage of IoT. So naming nomenclatures, you have studied in your chemistry 12th standard the nomenclature of carbon, hydrogen, all those stuffs. Similar thing happens here. I have tube light here, so the both lights are tube lights, right? So I call this one as a tube light 1 and this one as a tube light 2. So what happens? I say if I said turn on the tube light, what will happen? Any guesses over there?
Both lights get on.
Yeah. Okay. Okay. Let's see. Alexa, turn off the tube lights. A few things share the name tube lights. See, I have already pre-assumed that this one is tube light 1, this one is tube light 2. So I have to give the correct name. The correct nomenclature has to be there. See, tube light 2, I have told it will have turned off. Alexa, turn off the tube light 2. I guess this one is- Alexa, turn off the tube light 1. See, now it's clear, right? So these are some of the disadvantages of IoT. If you're building out it on your own. Anyway, if it is connected to the Alexa or something like that, uh, uh, the system's integration to the cloud will determine how well your IoT is going to be working in. So I have a 100 Mbps internet here. In a country like India, let's assume in a country like India, what is the probability that you will be getting 100% internet 24/7? What is the probability? Anywhere between 70 to 80, right? Okay. So if you're implementing a IoT system in any medical services, let's assume you are implementing the IoT services in a medical service, or you are implementing the same thing in a military services. If you're not having a proper internet with 100% assurity, what will happen? If it is in a medical field, a very massive things can go wrong. If it is in a military thing, military area, we'll be lost. We'll be completely lost. Our soldiers will be dead. Okay. So these are some of the disadvantages when it comes to the Indian scenario. And I can also show you that. See, I have two applications in my mobile. This one is called Blink. So I'll come to that later. So this is basically a interface from my phone to my IoT devices. Okay. So all those, this is for the room in the ground floor. Okay. So if I turn on these things, my tube lights will be turned on there. So what is the issue here? For this, a specific code, a specific alphanumeric code is there, a 16-digit one. So that is a security issue. If anyone is having the same code in their hands, and if they are installing the same application, they can control it from anywhere in the world. See, my brother is in currently he is in Calicut, around 300, 200, 250 kilometers from here. Even if he is having a good data connection, and he is having the same app with the same code, he can control the appliances from there. Okay, he can control the my house appliances from there. This is the another issue, the security breach. Okay, so this is one of the applications, and also we have the Amazon Alexa applications here. So if you see here, this is the Amazon Alexa app. In the bottom side, devices you can go. So I have customized all these devices. If you see here, see, now if you see which all are on, the light bulb is on, the fan is on. So I'm turning off the fan. Okay, I'm turning off the fan. See, the fan has been turned off, and the light bulb, I can turn off it here. See, this is the advantage. So the remote accessibility is one of the major advantages. So usually the Indian household people have a very weird habit. Like when you're going for a trip, after around 1 to 2 hours of driving, you will be thinking of yourself. Have I turned off the tube lights? Have I turned off the water pump? Have I turned off the mixie? All those things you will be having the doubts after 1 hour, 2 hours of drive. So if you're having such a system in your hand, it's very handy. See, you can simply look in this application. Let's see which all things are on right now. If anything is on, you can completely turn off from here. Okay, provided that you have a good internet connection and a stable electricity connection. So these are the two, what do you say, necessity for IoT. So are these points clear for you? Any doubts in that?
Yes, sir. Clear.
Yes, sir.
Okay,
It's clear, sir.
okay. Was that good? Was that good? The practical demonstration, was that good?
Yes, sir. It was very interesting.
Okay, okay, great,
Yes,
great.
It's
sir.
amazing, sir.
Okay, okay, yeah, sure. So I can show you the circuits or things like that. So I'll show you some of the other things that I made, uh, and you will be getting a lot of demotivation from your parents. Okay, it takes whenever I design something related to the IoT, I always try my level best to keep it in a minimal manner, and also not bulging out from the walls. I just need it to be integrated to the wall, just like in the Iron Man films, the MCU films. Okay, sorry for that. Yeah, so anything in the integrated form, I like it very much. So if you see here, I can show you how I did the IoT in my switchboard. See, I built another box and I uh, cracked open the wall. I just fitted everything there. Okay, so this is an integrated system, so I don't have to worry of the beauty, the aesthetic purposes. I don't have to worry it anymore. Now, if you see, let's. Okay, these are some of my other IoT projects. Yeah, so this is the system that I implemented here. So if you see, I'm having a main controller unit. So this is a node MCU board. Okay, node MCU, I'll come to that later. This is a relay. It's an electromechanical switch, which means you can give an electrical signal to have a mechanical connection. Okay, and the whole thing to power on, you have to have a power supply. Okay, so this thing has to be reliable. I'll come to that. And if you see here, so this is how I integrated things. It's not coming up. And this is the IoT cloud. Okay, so IoT cloud, I won't be getting that into much. Why? Because it's actually, what do you say? It's not a beginner friendly thing. Okay, I'll come to that later. So these were some of the things that I need to show you, and yeah, why IoT, all those things we are showing up here. Give me a minute. And why not? So design considerations. We have seen these things. Okay, in the latest slide, or when I asked you what all things we can automate, you have already told me which all things we can automate. Now we can go how we can design those things. Okay, so let's assume we are going for. Okay, can you just give me some suggestions? So for a motion sensing light, who told me that? Who told me this idea of motion sensing light? Anyone? My screen is visible, right?
Yes.
Yes, sir.
Okay, okay.
So probably we can use PIR sensors.
Okay, great. Yeah, we are having a PI sensor. Then what should I need? It should be
Mm,
connected to what?
Arduino. No. It
Arduino.
should, yeah, it should be connected to Arduino,
Okay,
and
then
another part should be connected to your,
yeah.
I guess, some
Light.
modules and then light.
Okay, yeah, something like a relay or any
Relay
other
module, relay module and then light.
light. Okay, if I need to connect this to Wi-Fi, I can have a Wi-Fi module here, right?
Right.
Okay, then the whole thing has to be. Yeah, I'll come to that later. For the fan, what can I use? What can I use? Fan. So suppose this is a situation. If the temperature goes below 25 degrees Celsius, I want the fans to be turned on. Okay, above 25 degrees Celsius, I need the fan to be turned on. Which sensor I can use?
Temperature sensor.
Temperature sensor. Yeah, I'm using a temperature sensor again, a microcontroller like Arduino. Again, I can use a relay or SCR is there, a solid state relay, SSR. Solid state relays are there. Then I can use the fan. Refrigerator, a similar setup for the temperature itself. Then automated water pump. What can I use as a sensor? Come on, guys. You actually you are very responsive. Very responsive. Automated water pump. What sensor I can use?
So we can use that ultrasonic sensor to detect the level of water so that
Okay.
if it reaches above that, then we
Okay.
can turn off.
Okay. Let's assume I'm using ultrasonic sensor. Any other suggestions for the ultrasonic sensor? Any?
Sir, I don't know the particular way, but if
Okay.
we like drop some wire to two wires separately, one for
Mhm.
input and one for output,
Yeah.
and program in it's such a way that if it conducts and
Right. Okay.
yeah,
Thank you for that. Yeah. So this thing is known as a hygrometer. Okay. The same principle as you have told. It will be having two leads, and the water when it touches, it will be having some conductivity through the water. Okay. Now, any other sensors that can be used?
Capacitive water sensor.
Capacity water sensors. Yeah. Tell me. Okay. Let's assume. Any more? Any more?
Gas sensors for
Uh,
detecting CO2 or any gases around this.
okay. Let's assume that also. Gas sensors. Okay. And the relay or relay would be used in such a way that you are using an induction motor, right? Induction motor consumes around 7 to 8 times of your starting current. Okay, the starting current will be high, so you have to design that properly. Let's leave that alone. Now let's consolidate this data. What is this? What is this area?
Sensors.
Sensors. So the first block for what do you say, the IoT or the automation part is sensors. Choose your proper sensors. Okay. The table haven't got right. Mm, 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 mm. Yeah. Then what? What is this? What is this thing?
Microcontrollers.
Microcontrollers. Yeah, correct. So this we need a microcontroller. So this is the very basic block diagram of a IoT system. And what is the other part? Anyone know? Anyone know this part?
To control the
A stimulator kind of thing.
Right. We can call this as actuators. Okay.
okay.
Okay. This thing can literally actuate things, actuate the motion. And the last one will be
Things.
things. Correct. Correct. Thank you for that. Thank you for that. So this is the very basic block diagram of a Internet of Things. Okay. Very basic block diagram of Internet of Things. And if you see here, if you need the Internet of Things part, you have to connect it to the internet. Let it be Wi-Fi or any other protocols. You can use any other protocol as there are no certain standards as of now. And to support all these things, what do you need? To support all these things, what do you need?
Motherboard.
Um, we have the microcontroller. We have the microcontroller. For these things to be turned on, what do you need?
Power.
Power. Right. A constant power has to be fed. So this will be a power source. So is this, what do you say, the block diagram clear for you?
Yes,
Yes,
sir.
sir.
So now you can
Yes,
remember
sir.
these things, right? Without what do you say? By hurting things, you can take it from your memory, right?
Yes, sir.
Okay, perfect. Now let's see. Now let's see. So just one thing I have to confirm here for the ultrasonic. So this is how sensors work. Sensors are those modules which actually convert any of the other energy forms or any other forms to voltage. Any other forms to voltage. I'll just show you that. Give me a minute. See, temperature sensors. If you're from electronics background, you may know that you studied transistors. It will be having the base, emitter, and collector will be there. Base will be in the center. Anyway, I'll leave that. So if you have some supply, when you give some supply to here, you will be having the flow of electrons from emitter to the collector. This is the basic working principle of a transistor as a switch. So what happens? You can emit this base by different methods, right? You can emit the base by voltage, using current, and using temperature. Okay. So what happens if I heat this place? What happens if I heat this area? More current will be transmitted from here to here, right? So these two terminals will be given to the Arduino. Okay. These two terminals will be given to the microcontroller. Now what happens? Whenever there is a temperature, the voltage fed into the microcontroller will be changed. This voltage will be higher or lower depending on the temperature, right? So what ineffectively what happened? A varying what do you say temperature has been converted to its equivalent voltage, right? This is what happened. Let's see what happens for an ultrasonic. Okay, let's see. This is an ultrasonic sensor. Okay, this is an ultrasonic sensor. So if you're not familiar with ultrasonic, it's basically the bat band. Okay, it's a bat. How they catch the prey? They emit a wave of ultrasonic waves, and this will hit in something, and the thing will be coming back. So it will be hitting what? It's not hitting an object. Okay, it won't be giving you a signal when it hits an object.
It may look
It
something like this, right?
I didn't hear that. Can you just repeat?
I have turned on my camera. If you can see,
Okay,
it
okay.
looks
Give me a
something
minute.
like
Yeah.
this.
Yeah, right. Correct. This one is only the ultrasonic sensor. So yeah, thank you, Pradeep, for that.
Yes,
So
sir.
if you see, it will not be giving the object. It is not object detection. It is obstacle. Okay. Object can be your phone, you yourself, your computer. Anything can be an object, but an obstacle can be even the minute particles of air. Okay, even the minute particles of air can be detected by this ultrasonic sensors. And how you detect where this thing is? So you know this is ultrasonic. It's a sound wave. Okay, what is the velocity of sound? It's 340 meter per second, and you know that distance equal to velocity into time, right? So distance equal to 340 meter per second, and you know what is the time period that it takes from this point to this point. It will be total time divided by 2. Why 2? It have gone to and fro. Okay, so now you get the distance as 10 centimeter, 12 centimeter, etc. So this is how you measure the distance. Okay, again, the distance has been converted to its equivalent voltage. Okay, so if I put this sensor into my water tank, what happens? If I put my sensor into my water tank, what happens? The sensor will be giving some rays to my flowing water. Okay, flowing water, and the ray will be deflected back. But what happens as my wave is having a okay wavy nature? The wavy nature is there. So what happens? It is not required that every single wave hitting the spot will be deflected to here. It can deflect it to there. It can deflect it to here. It will be some dispersed into inside of the water. Some will be getting back. So what happens? We'll be sometimes getting a wrong value. This is the reason why we don't prefer the ultrasonic sensors. Okay. Hygrometer sensors, a very good example for the sensor that we can use in our automated water project. So if you see, this is the very simple drawing of a hygrometer. So the same happens for the capacitive sensors also. Okay. So this will be having some metal plates here, and this is put into the water. When the water level is rising, you can get the data. So what happens? If you give know the equation for capacitance equal to I forgot the okay. Anyway, it's directly
TYV.
proportional to yeah. No, the other equation d by a. It's proportional to the distance between them and the cross sectional area, right? So if you see, this area is a constant. So d is a constant. Now what? C proportional to inversely proportional to the area. So whenever the water is touching here, the more area it is conducting, the less capacitance it will provide. Okay. And that capacitance is converted to the voltage. Again, a voltage ranging from 0 to 5 voltage. This can be taken by a Arduino. This can be taken by a Arduino. But what is the real issue here? If you see, the real issue happens in these two metal plates. Metal, of course, you know, the water from the well, it's always a mineral water. It's not a distilled water. So it will be having some minerals, and this minerals is capable of degrading the metal. Over the time of 2 to 3 months, this metal will be degraded and the sensor will not be working properly. And again, it will give a wrong value. So hygrometers and capacity meters are not that much effective. It's okay. It's for experiment purposes is okay. For the gas sensors, again, it's a having another configuration. I'm not very capable of delivering that. Again, we can let's assume this is the tank, and we are having water here. So the water and so in the water there won't be any gases. Okay. So in here, this is free space. This is free space, right? So this free space can be detected by the gas sensor. Let's assume the gas sensor is now blocked by the water. Now that can be fed as a data. It can be possible, but again, this won't be that much realistic. It won't be that much, what do you say, feasibility. The feasibility of such a sensor is not that good. So a very feasible and realistic solution for this purpose is known as a, what do you say, the float switches. Okay. Have you seen the float switches? Anyone seen the float switches? No, I
No,
guess.
sir.
Okay, no problem, no problem. You have everyone is having their own bathrooms, right? And once you flush, okay, the flushing mechanism, how the flush tank works. Have you ever opened that thing? It will be having some kind of balloon here. Okay. Whenever the water is getting into a higher position, this thing will be going up. Why? Because it is having a vacuum inside. Okay, this thing will be going upside such that it will come to a state where now it is like this. So what happens? It's actually actuating. It's actually actuating. Here a motion is happening. See, this degree of motion is happening here. This degree of motion is happening here. Okay, this degree of motion is happening here, which ineffectively turns on a switch or a valve for the water. Here, if it is here in a flush system, it is a inlet valve. This thing will be closed once this bowl is in the upper position. The same technology is used for the float switches. Instead of the valve, it will be using a mechanical switch. Mechanical switch will be used. I can show you that float switch. See, this is the practical solution for that. If you see here, you don't have to mind these pictures. This is a very common picture. Yeah, see here. See this one. This one. Okay, I'm not. See this one. This thing will be going upside, and what happens? See, this thing will be going upside, and our internal switch will be activated. So this is how the sensors work. Okay, now you get an idea of how the sensors are working, right?
Yes, sir.
Okay, till now things are clear, right?
Yes, sir. Clear.
Okay, done.
Sir, it's conduction, sir. When the two parts touches, there will be conduction, sir.
Which one? Which one? For the which sensor?
You have shown the float switch, no, sir.
Right, right. So what is happening internally in the float switch is that, so this will be the, okay, you need a switch. Switch is having two terminals, right? So yeah, so this way two terminals will be there, and this thing is enclosed in a plastic box, and it will be having a plastic body, a plastic insulated body, something like this, sticking out of this box. Okay, and it will be
Yes,
having
sir.
a something like this one, and the internal will be vacuum. Okay, now what happens if the water is getting above this area? If it is getting above this area, what happens? This will be moving up, right? So now the new position will be somewhere around here, right? So what happens? Ineffectively, what happens? This will be, okay, I'll use another color. Ineffectively, what will be happening? This thing will tend this single plate to touch the other plate. So what happens? Internally, a switch is closed, and you can take the switching terminal from here. Understood?
Yes, sir.
Okay, okay, done. So design consideration, what all things needs to be automated. So if I say that I'm using an automated system in my house to control the lights, so this is basically it's not that good. Okay, it's taking my energy. So if you say I was in a software job for the last not this year, from 2020 to 2021, I was in a software wing, DXC Technologies, and at that time I just built all these stuffs. What happened is that I'm continuously in front of my computer, right? I'm continuously in front of my computer. I'm seen, right? You're able to see me, right?
Yes,
Yes.
sir.
Yes,
Okay,
Abhi.
great. Yeah, sure. So think of a situation. I'm sitting in this rolling chair here, and I'm having the complete automation system in my house. So I don't have to even get up from here to just turn off the fan. And if I just slide from here, I can go to the bathroom, I can go to the bedroom. See, I'm not even standing up. So any technology, if it is overwhelming, if it is overqualified for your appliances, will make you a dumb person over the time. Okay. So I used to do a lot of welding and all those stuffs in my house. So I'm kind of a practical stuff. I'm a man of practical stuffs. So if I do not have such a skill, or if I'm not something like that, I will be sitting entirely here for my rest of my life. I won't be even getting up for turning off that switch. So everything is in my control. So if I need to turn on the fan, I can just say, Alexa, Alexa, turn on the fan. If I say something like that, it will be turning on. See, I don't have to go there, turn on the switch. So it is ineffectively making me a lazy man. Okay, Alexa, turn off the fan. Okay, so um, let's wait for the Alexa to shut up. Okay, yeah. So when you are going for the design considerations, you have to choose which all things you have to automate, and think twice whether it really needs to be automated. Okay, I automated my water pump. Why? Because my mother has a tendency, whenever there is a overflowing water, she runs to the bathroom to just turn on the tap to save the water. Ineffectively, the water is going to the groundwater again, right? Still, she will be running. So I don't want to see that anymore. So I just automated my water pump here. So the real necessity of things has to be discussed in the first place. And the second thing, we have already got an idea to the uh, sensors, which all sensors you need to be using. You can simply use a Arduino and a Wi-Fi module. But what happens is that simple board like Arduino and Wi-Fi module will be costing you around 400, 450 rupees. But a single board like Node MCU, ESP8266 Node MCU will be costing you around 290 rupees, and you will be having the same advantages of using a Arduino and using a Wi-Fi. Okay, so these two modules combined is a Node MCU. You can use that. And the sensors, we have talked about that. The relays, we have talked about that. If you go for the induction motors, you are going for a water pump, you have to rate your relays in a such a way that it can take up the starting current. Okay, so if you go for the induction motors, it will be having a starting current something like this, and it will settle up. Sorry for that. So this will be around 17 amperes, and this will be around let's say 8 to 9 amperes. So your relay must be at least rated for around 30 amperes. So these are some of the design considerations that you have to do. It's a topic for another session. Okay, so a very brief introduction. Design considerations, if you again go for the wires, the signal wires has to be solid wires, not stranded wires. Why? Because it is transmitting signals, right? So any interferences can be happen in between. So you have to be careful about choosing your wires. The power adapters, it must be qualified well enough. It should have a definite qualification. You can buy the cheap adapters for 50, 60 rupees. It won't be lasting. You have to go for SMPS power supplies. Okay, something like that I shown in my LinkedIn profile. So if you're going for something similar, you'll be having a longevity and the reliability of this whole system. So wires and power supplies are another thing where you have to spend a lot of money. Sorry. And again, if you're going for Amazon and all those things, do not go for the Amazon and Flipkart. Okay. So I'm not boasting about myself. I'll just show you something. So in the AliExpress, okay, now the site is banned actually. So AliExpress was the site where I used to purchase everything. So if you see a single module where it cost 140 in Amazon, in AliExpress, the same module you can purchase it for 15 rupees, around 10 times difference. Okay, but now it's banned. And coming to the boasting part, I was the only customer in India to buy around 396 components from AliExpress, and I was awarded the gold medal for that. So now the shipping charges for me is free. Okay, but what happens? Uh, the AliExpress is now banned in India. Okay, anyway, you can go for the robo.in. It's a good website. DigiKey is a good website. Thomas Electronics, it's a electroniccomponents.com. It's a good website. And the least preference will be given to the Amazon and Flipkart. They are killers actually. They don't sell. They are not well enough to sell these electronic modules. Okay. Now these are some of the tips that I can give you compatible to your appliances. Make sure that all the modules are compatible for your appliances, and make the wires very short, very short, so that the interference can be reduced. And you can use a Node MCU over the Arduino plus Wi-Fi, so you can reduce the cost. And all things has to be well protected in a case, like I have shown you. And also beware the quiescent power. Okay, the quiescent power, the IoT has to be turned on for 24/7. So if you see, the whole system that I built is consuming around 1 watt. Okay, if you go for the 1 watt into two systems, I have did two systems. So 2 watts is consuming and 24 hours. See, 48 watts hours it's consuming. It's around 48 watt hours. And if I use it for 60 days, okay, 2,880 watt hour divided by 1,000, which means 2.88 units or approximately 3 units. In my place in Kerala, for a single unit, the cost is 5.5 rupees. So I'll be charged around 15 to 20 rupees for 2 months. Okay, for this IoT system entirely to work on. So a quiescent current or the power is already consumed by the IoT. Okay. And developing a code, the code part is very hectic actually. I hate coding. So the power of open source, the Arduino, every software is open source nowadays. So you can borrow someone's. Okay, so don't do that. Preferably the one develop your code. I don't do that. Okay, being honest with that. And you can integrate the things with your mobile IoT application. You can build that one. You have the MIT App Inventor tool. So if you go for MIT App Inventor tool, you can make your own application. Okay, for free. These are also open source one. So things like that you can use. Now design consideration, I'll just show you my. I have did a lot of such projects. Just seeing where it is. Okay, not this one. Yeah, YouTube. I have a YouTube channel. You don't need to subscribe for that. It's actually in a local language called Malayalam. Okay, completed. Automated pump. So this was my automated pump. Videos, yeah. See, I used all those things. So how many of you are interested in seeing the working of a relay? Anyone? Anyone interested in seeing the working of relay? Is it yes or no? Okay. Sure. So what I usually break stuff. I don't see them. I don't like them seeing in a good condition. So I usually break stuff. So this is the internal working of a relay. The internal contacts. Okay. So this is the electromagnet. Okay. This is the electromagnet. When it is energized, this portion will be sticking to this thing, this metal portion. See, this is how the relay works. I have a good camera, so that's how I get it. Now I designed all the system with a local power supply. So this was a really drastic thing. So I had changed the power supply. The relay is here. I don't had a internet here. Why? Because I just needed to be automated. Okay, I used a 8010 It's a what do you say, younger brother of Arduino, and a hygrometer. Okay, hygrometer I used in first place. I changed it to float switch now. See the whole system. Now, if you see, I have told about the current. I have told about the current, I guess. See, whenever you turn on your motor, it will be taking a starting current of, see, 11, 11 amperes. It will take a starting current of 11 amperes, and then it will fall down to around 4, 6 amperes. So that is the inrush current. And what happens is that the hygrometer, as I already told, what happened? It degraded over time. The hygrometer degraded over time. So first option was I just replaced it with some pins. Okay, thinking that it won't be corroding. But again, this thing also corroded. Now I changed that to a float switch. So this is how you can experiment with your IoT systems. And whenever the water tank get filled, a light will be turned on there. This is how my system was. So I usually do a lot of systems. So this is how the system works. So my mother is in very support with me. She actually like me destroying things. Anyway, kidding. Yeah, this is a hygrometer, a very basic thing. So what I did is only after 5 seconds of turning off the entire system, the relay will be activated. So that for the 5 seconds, it will be in a off state. See, I turned on the switch, everything is turned on, and after 5 seconds only the relay gets turned on. See, now the relay is on, the water pump is on. Now, if the hygrometer is touching, having the water, the system will be turned off in such a way that once it's turned off, it won't be turned on for another 3 days. Okay, so these are some of the things that we can see. Yeah, I missed one topic, I guess. It's no problem, no problem. Yeah. Anyway, now coming to the career part actually it's massive. If you just simply search in your Google Industry 4.0, a lot of plenty of job is coming up there where if you are well enough with the Internet of Things. So Internet of Things doesn't mean that simply working with your Arduino is Internet of Things. Okay, don't assume that. So you have a different area when you're working, when you are looking for a career in IoT. Career in IoT. So you have, if you're good in programming, you can go for the backend developers. Backend developers, there are opening posts by many companies. Uh, then UI UX, the front end design for the what do you say, for your mobile phone. Okay, front end design is there. Then the electrical system designs are there. Electrical system design. So where you design all those stuffs, as I already told, the relay and all those stuffs for designing that, and the Wi-Fi. So the communication part, electronics and communication students, you can go into this one. Sorry for the language. Yeah, communication part where you have to understand about regarding the different protocols used in the IoT systems and all those stuffs. So this is how the jobs, the careers are divided in the IoT segment. Okay, so I guess for any career or other doubts, you can connect me with. You can connect with me at any time, and this is my contact. I'm not in WhatsApp. I'm only in Telegram, so you can. Okay, just you can take down this number. Okay, so I guess we can wind up. It's 10:05, and thank you for bearing with me. So, can I get some suggestions of how the session was?
Yes,
So
really
it was
amazing.
very interesting, and we got to learn many new things.
So
Okay, yeah.
informative, Anna.
Okay, okay, yeah. Thank you, guys. Thank you. So I guess we
Yes.
can wind up the session, right?
Yeah, so some of the questions.
Yes, sir.
Yeah.
So, like you said, that the automation part is going to affect the job prospects of many sectors. So, what is the way to fight that particular thing? Like, how will we manage to provide job to the less skilled people?
Let's skill, yeah. So
Yeah.
I'm not trying to promote my company or something like that. So there are platforms where the upskilling part is done. So if it is the electric vehicle, so my company is basically into that field where we are upskilling the people. Whenever a new technology comes in, you have to first upskill the existing people. The existing people has to be upskilled. So there are many courses, many online courses where or regarding the IoT itself, where you can get upskilled yourself, okay, on the segments. So what all things that we told just right now today, these all are basic understanding, okay. When you are into the in-depth knowledge of IoT, you have to learn a lot of things regarding the protocols, IEEE protocols. All those steps has to be learned. So fighting this industry 4.0 is kind of upskilling yourself to fight the industry 4.0 or the future of IoT. You have to upskill yourself, and this can be done through many courses and other stuff. The practical experiments has to be there. All those stuff has to be. Anyway, there will be a time when most of the people, around 90 percentage of the people will be their jobs will be cancelled or they will be rejected from the company, okay. There will be a situation, and there are reports available in the internet all over. I usually go through these things, and I saw that a report saying that by 2040 around 80 to 85 percentage of the total workforce will be completely rejected, okay, and new workforce will be devoted, or the existing workforce will be upskilled to match the industry standards.
Sir,
Okay. Yeah.
Okay,
Yeah.
sir.
Okay. Okay.
sir, can you suggest any app or website to learn the IoT to gain
Uh,
knowledge?
okay. Okay. So, the knowledge that I have, or it's kind of industry standards we are requiring. If you're going for industry standards, the government of India, you can search in internet like IoT courses by government of India. Okay. So there will be industry standard procedures for that. So you'll be getting certified courses, okay, but it will cost around about 10,000. It will be costing around 10,000 and about 10,000. Still, you'll be getting a certificate. What do you say? The certificate, okay. If you're not into that and you are an enthusiast, then you can go for the YouTube. I studied. I learned a lot of things. Most of the things, around 70 to 75 things, I learned from YouTube only, and rest from the test books. There are a lot of test books on the, it's not basically on the automation part, but it's on the designing part, the analog electronics, the power electronics, all those stuffs. We have to be aware of that. Only then we can design a system. So what I suggest is that you can go for the YouTube channels. A lot of YouTube channels, Indian YouTube channels are there. IoT maker clubs are there. In the Quora, a lot of clubs are there, and also you can go refer some your old 12th standard physics. That's better for your IoT education upskilling, as if you are a part of an enthusiasm.
Can you retell the components of IoT once again, Anna? I shall note it.
Okay.
So
So
maybe you can save that page and share it with us.
right.
We
So it
can
will be
provide that details. We have taken the screenshots and all, so we can provide
okay.
those details.
Sure. I'll just convert this PDF to a PDF, and we'll send you that mail. You can share with the participants, I guess.
Yes, sir,
Yes.
we'll do that. Sure.
Okay. Done.
Yes,
Okay.
sir.
Yeah. Thank you, Lokesh.
So,
Yeah. Anyone?
move it,
Any?
move it. Then,
Okay.
Tari,
So thank you a lot for the session. It was very interesting and we enjoyed too much and we also learned many things.
Yeah.
Now I would like Mona Lisa to give you some words.
So, sir, I'll proceed with the vote of thanks. I, on the behalf of the Instrumentation Society of India, VIT chapter, would like to extend the vote of thanks. I take the opportunity to put all our gratitude into words. I would like to thank our speaker, Mr. Abhinav Rajeev, for taking his precious time out and agreeing to be the speaker for tonight. We are enlightened by your knowledge and presence. Thank you for clearing our concepts and enhancing our understanding of IoT. Indeed, You have put your best efforts to make this event unforgettable. We owe you a lot. Last but not the least, I thank all the students for showing their interest in the session. I once again thank everyone for making this event a success. Thank you, sir. Thank you, everyone.
Yeah. Thank you, Mona Lisa. Thank you.
Thank you, sir, for the
Thank
event.
you, sir.
Yeah.
Yeah,
Thank you,
sure,
sir.
sure. And don't think that IoT is the ultimatum thing. Okay, so there are at times where this Alexa, this bloody thing has get my job into the verge. So I was having a meeting with my director, the company director, and this thing all of a sudden started its own, and it started to switch the lights and fans on its own. Okay, so there would be errors. Okay, don't consider this to be an ultimatum. Again, it's an introduction section. Thanks to be here. Like, thanks a lot, the IC chapter and Prajwal. Thank you for
We're
this.
looking forward for a specialized
Thank you, sir.
session also.
Sure, sure, sure. Yeah,
Yeah.
you can connect with me.
Thank you, sir.
Okay. Yeah, thank you guys. Thank
Bye.
you.
Thank you,
Bye.
sir.
Thank
Yeah.
you so much, sir.
Thank you, sir.
Okay.
Thank you, sir. Thank you, sir.